Let's look at some examples where we calculate the accumulated value at compound interest. Pause this video and take a moment to review these expressions which we will be using. In our first example, we are asked to find the simple interest on $1,000 for 2 years at 12%. So note this is a simple interest problem where the principal is 1,000, the time is 2 years, and the rate is 0.12. Remember, you have to convert from percent to decimal. The interest then, simple interest, is simply the principal times the rate times the time, and that gives us $240. Now, in this case, we are asked to find the compound interest on $1,000 for 2 years at 12%, just like the previous problem, but now compounded semi-annually. This means twice a year. The principal is 1,000, but now we have 2 conversion periods in the year. So M is 2, and so we express our interest rate then as 0.12 compounded twice a year. That's why we have J2 here. The interest rate for each conversion period then is going to be 0.12 divided by the number of interest periods, in this case 2, which gives us 0.06. And since it's for 2 years, then we're going to have 4 interest periods. We can't calculate the interest directly. What we have to do is calculate the accumulated value. And so for that, we have this expression. And so we simply substitute into it 1,000, 1 plus 0.06. Remember, this is the interest rate for the conversion, for each conversion period. And then this is the number of conversion periods we have. So this becomes 1,000 times 1.06 to the 4th power. You need to know to use your calculator to calculate this. And once we have the accumulated value, then the interest is simply the difference between the accumulated value and the principal, which gives us $262.48. As we expected, compound interest gives us more interest. So simple interest on $1,000 for 2 years at 12% gives us interest of $240. Whereas compound interest on $1,000 for 2 years at 12% compounded semi-annually gave us $262.48. So the difference here then is $22.48. In this problem, we were asked to find the compound interest on $1,000 at 6% for 5 years, compounded every month. And we're asked to find the compound interest for the same amount, $1,000, at 15% for 30 years, once again compounded every month. In other words, compounded 12 times a year. So for both these problems, the principal is going to be $1,000, and the number of conversion periods will be 12 for the year. For part A, we have that the nominal interest rate is 0.06. The interest rate for each conversion period, since there are 12 of them, is going to be 0.005. You get that by dividing 0.06 by the number of conversion periods. So how many periods do we have in all? Well, it's 5 years and it's 12 per year, so that gives us 60. And so now we're in a position to calculate the accumulated value using this expression, 1,000, 1 plus 0.005 raised to the power of 60. This gives us $1,348.85. And from this we simply subtract $1,000 to give us the interest, which is $348.85. In part B, the nominal interest rate is 0.15. Again, there are 12 periods, so the interest rate is going to be 0.0125. 30 years in this case. So 30 times 12 gives us 360 interest periods. Using this very same expression over here, the principal is 1,000. 1 plus I, 1 plus 0.0125 raised to the 360 power. That gives us, using your calculator, 87,541. The interest then, subtracting 1,000, is $86,541. Here we are told that $1,500 is invested for 18 months at a nominal rate of 13%. Find the accumulated value if interest is compounded, in the first case monthly, and in the second continuously. So in both cases, the principal is $1,500. For the first part, we have that M is 12, that is 12 conversion periods for the year. The nominal interest rate is 13%, 0.13. So for each period, it's going to be 0.13 divided by 12. I will leave this expression as is because rounding off will throw off the answer too much, so I'll just leave it like this. So we have 18 conversion periods, 18 months. So using this expression here, we simply substitute values and we get that the accumulated value is $1,821.06. In this case, the interest is compounded continuously. So the nominal rate is still 13%. And the time here is going to be 1.5 because here we express the time in years. So we don't concern ourselves with interest periods because the value of the length of each interest period is essentially 0. So it's 1.5 years, 13%. And so since it's compound interest, we have to use this expression. So here we have the nominal rate, 0.13, and we have the time, 1.5. 18 months is 1.5 years, right? Using this expression, we can simply calculate that the interest is $1,822.97. So the difference isn't so great. The difference here is only $1.91. So that brings us to the end of this short little video.